Hi everyone, I am Balaji Chipada and welcome back to my YouTube channel. In continuation of our series Probability and Statistics, in this video we are going to learn some topics which we already know, but I am just going to rephrase all of those things for you. So we are going to learn what is mean, what is median, what is variance and what is standard deviation. So we will understand all of these things in detail. We will also understand the intuition and we will also understand how you can do the calculation part as well. So without any delay, let's get started. So let's start by understanding what is mean. We have already know what all of these things are. This is just a rephrase of all the things that we already know. So mean is basically average. So let's say I have a couple of points x1, x2, x3 and x4. It could be any numbers, it could be anything. And if I want to calculate mean, the formula is like this. So let me explain what this formula is. N is basically number of elements. So in this scenario we have four elements, and what we need to do, we need to sum up all the elements and this I value going from 1 to n for all the elements, and then we need to divide the total by the number of elements that we have. So this is basically x1 plus x2 plus x3 plus x4 by 4. So this is the mean of all of these points x1, x2, x3 and x4. This we can also represent like this: sigma I equal to 1 to n xi by n. So this is the mean of the points that we have, and it is mostly defined as the most common central tendency representing the average. It provides a single value that summarizes the data points in the data set and gives an idea of the general location of the data set. So what this means by general location, so let me understand what is happening. So let's say I have 4 points: 1, 2, 3, 4 and 5. Let's assume like this. And on a scale, I will have 0, 1, 2, 3, 4 and 5, right? And if I have to calculate mean of all of these things, it would be 1 plus 2 plus 3 plus 4 plus 5, which is 5 plus 4, 9, 10, 12, 15 by 5, which is 3, right? So the mean is 3 and this is the mean value. And if you look at it, the distance from the first point to the mean and the last point to the mean is almost same in this scenario. So not always this is going to be right, because if you have very huge variety of numbers that we are finding, trying to find a mean, the mean might not always be at the center location. It depends on what kind of numbers we have, but it gives you a sense of the center. That is what it is mentioning. It gives you an idea of the general location of data points. So it gives you the mid value. So what if I have 10 here? So I will have to add 10 here. So this will be plus 10, 15 plus 10, 25, 25 by 4, which is approximate 6 point something. So it is not in the center. It is shifted towards the right side because we have a huge number on the right side of the scale. Hopefully that is clear. So this is everything regarding mean. And let's move on to median, and then we will understand what is median, and then we will also understand variance and standard deviation. So let's go to median. So this is the equation, which is the median is the middle value of the data set when it is ordered from the smallest to largest. In case of median, it is very important that it is always an ordered collection. I will explain with an example, so don't worry. It is a robust measure of central tendency, which is less affected by the outliers and skewed data of the mean. So let's assume I have the same ones: 1, 2, 3, 4, 5 and 10. So the mean of this is approximately 25 by 4, which is approximately 6.12, something like that, right? And it is not centered in, if you take a scale, because we have a point 10 which we call it as an outlier. We will learn about outliers in detail, but at a high level, what is outlier is, look at all the other numbers and look at this number. This number is very far right and very big compared to all other numbers. So a point which is something unusual is called as outlier. And in terms of outliers, the mean value is not going to be centered. So what we have to do in this scenario is we can use a statistic called median. So first we need to sort these values. Right now all of these are sorted, but what if my input is something like this: 3, 2, 1, 4, 5 and 10. So in this scenario, if you want to find median, first you have to sort this from smallest to the largest: 1, 2, 3, 4, 5 and 10. And now count the number of elements: 1, 2, 3, 4, 5, 6. Total 6 elements. That means it is an even number, right? Even number of elements. So how do you find the middle value? So that in case the total number of elements is even, then the middle value will be the average of these two values. So which is 3 plus 4 by 2, 7 by 2, which is 3.5. So 3.5 is the median value for the given elements. If you see, 3.5 is almost at the middle compared to 6.12 in a given scale, right? So let me explain that as well. So this is my scale. This is 1, 2, 3, 4, 5, and then I have 10. And when I calculated average, I got it somewhere 6.12, and it is not centered, right? But when I calculated mean, it is 3.5. So it is almost centered for the majority of points. So that is why median is helpful compared to average in terms of calculating statistics. Hopefully that is clear. Now there might be scenario: what if my number of elements are odd? Because we have seen even, right? What if the number of elements are odd? If it is odd, you have to take the middle value. So let's take an example: 1, 2, 3, 7, 10, 20 and 25. So in terms of this, these are all sorted right now: 1, 2, 3, 4, 5, 6. So this is the middle one, and this would be the median of these data points. Hopefully that is clear. So let me rephrase what is median again. A median is the middle value of the data set when it is ordered from the smallest to the largest, and it is the central tendency, and it is very less affected by outliers and skewed data. We will learn about what is skewed data as well, so don't worry. And to find the median, first we need to sort the data in the ascending order, and we have to calculate the number of observations. If n is odd, then you have to take the middle value, and if n is even, then you have to take the average of the middle two values. That is how you will calculate median in terms of a data set. Now let's go and understand variance and standard deviation. These two are important topics because we will be connecting these two with the normal distribution that we have been learning. So let me explain the definition first. Variance measure is the spread of the data points around the mean. I will explain what that is. It tells us how much the data value differs from the average. A high variance indicates the data points are spread out widely around the mean, while a low variance indicates they are clustered closely. Variance is calculated by averaging the square of blah 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 we have. So let's understand the formula and let's understand the intuition as well. So let's say I have 1, 2, 3, 4, 5, all of these points. Okay. And then what we need to do, we need to calculate variance. So to calculate variance, this is the formula. First we need to calculate mean. And what is the mean of these 5 elements? Which is 3. Now to calculate variance, you take every element and you subtract that with the mean, and you square it such that even if it is a negative value, we'll get a positive value, plus 2 minus 3 whole square, plus 3 minus 3 whole square, plus 4 minus 3 whole square, plus 5 minus 3 whole square, by total number of elements 5. So this would be 1 minus 3 2, 2 square is 4, plus 2 minus 3 is 1, 1, plus 3 minus 3 is 0, plus 4 minus 3 is 1, 5 minus 3 is 2, plus 4 by 5, which is 4 plus 4, 8, 9, 10 by 5, which is 2. So the variance is 2 for these data points. So let's understand what this is. So what we have calculated, we have calculated the mean, and then from every data point, we have subtracted that mean. That means we are looking at how far the data point is from the mean, and then you are making a square, and then you are dividing by total number of elements. So this will give you the spread of elements. So if you say this is my mean, right, 3, and if I subtract the variance from my mean, this will be my minimum value. if I subtract the variance or if I add the variance to the mean, this will be my maximum value. So it will give you a number in which how spread your data from your mean. So let me explain that intuitively. So this is my scale 1, 2, 3, 4 and 5, and my variance is 2, right? So if I subtract 2 from this, I will get this value. If I add 2 from this, I will get this value, which is my minimum and maximum. So from my mean, how spread my data is. So that is what variance is, and it is indicated by sigma square. Clear? So hopefully that is clear. And we have something called as standard deviation. It is really like variance only, but it is basically a square root of variance. Standard deviation is the square root of variance and provides measure of the spread of data points in the same unit as data itself. It is useful for understanding the precision of data set. Now you might ask, if my standard deviation is square root of variance, then why do we need two separate entities, right? So let's say I have 1000 data points. So 1, 2, 3, 4, 50, 70, 90. Likewise, I have so many data points. And let's say my variance is 100. This number is little bit big, right? So what we are doing, we want to bring this number to the same scale of the data set such that we are doing a square root, which is 10. So it is the same statistic, but we want to scale down the number a little bit so that it will be useful to understand the value in terms of the data set. You can argue that both are same. I can deal with variance and I can deal with standard deviation. It's up to you. But standard deviation is sigma, variance is sigma square, and you have to square root of variance to calculate the standard deviation. Hopefully that is clear. So in summary, mean is giving the basic idea of central value, but it can be misleading if you have outliers. So to overcome that, we have something called median. It provides a more robust central value, especially useful when data distribution is not symmetric. We have seen this one, right? This plot in the last videos. So it is a symmetric plot. In terms of symmetric, mean and median is same. We will talk about that in the next video. But if the data is not symmetric or skewed, so if I have to give an example of skewed data, something like this. So this is skewed data. So in terms of this skewness, the mean and median will vary. In terms of that, median is really good statistic to observe. And then variance and standard deviation are measure of how spread the data is. If you look at this one, this is called variance. How spread your data points from my main data point. So variance gives you a squared results, which can be hard to intercept, while standard deviation is more intuitive since it's the same as the units data. Hopefully you understood the difference between mean, median, variance and standard deviation. So let's take an example and calculate all of this in detail. So I have 4, 8, 6, 5, 13, 9, 8, 10, 11, 3, 7, 9. So if I have to calculate mean, what I have to do? I have to sum up all the elements and divide by total number of elements. So which is 7.75, which is my mean value. Clear? And then if I have to calculate standard deviation, I have to subtract my mean value from each of my elements and square it up. So 4 minus 7.75 square is this much. So likewise, I have to calculate for all the elements, and whatever the result that I got, I will have to sum it up and divide by total number of elements. So this would be my variance. And if I have to do a square root of 7.85, this would be my standard deviation. That's all for this video, guys. In this video, we have learned about mean, median, variance and standard deviation and their intuition as well. If you have any queries so far, please let me know in the comment section below. And if you are learning what you are watching, please do subscribe and click that bell icon to get notified daily. We will meet in the next video. Bye bye.